Okay.
Yeah. Okay, sir.
Yeah.
Me also same. Me also same, sir.
Who is that guy? Yes.
Morarji, sir. I also paid fee, but I did not.
No. Yeah, Morarji 777, your email ID.
Yes, sir.
Yeah, 1 second.
Mine
Yeah,
is RSI 22.
Yeah, definitely. I'll check with online team.
Okay.
Yeah, these are the.
Mine is not there in it, sir.
Okay. Yeah. I'll check with online team. Definitely.
Okay.
Yes, I'll share. Yes, after finishing class, immediately I'll share it. Don't worry. Okay. Yes.
And sir, where will we find the link, daily link?
Daily link, already you have the link, right? Currently. Same link we are
Sir,
using.
actually we joined the group yesterday, so the previous ones we can't find in the group, sir.
If I click on that link which I used to click the last 3 days back, it is redirecting to some other class which is going to start at 7 o'clock, sir. So that's why I got confused.
No, I don't have. There's no batch. Yes, my batch. There's no other times. Only this is the time.
No, as others, sir. I don't know who is he exactly, but the name is showing the another search, and the timing is 7 o'clock. The same link which I used to click 3 days back. So that's why I got confused.
No. Why is 7 o'clock? At our time is 9:50.
Yes, sir.
Yeah.
Okay. I will
Same
just
link. So
confirm.
Monday shared that link. Right? Same link we can use every day. So till tomorrow,
Okay.
if any link changes are there, we'll inform you.
Okay, sir. We will inform in this WhatsApp group, sir, which you have created.
Yeah, definitely.
Okay. Then.
I'll inform.
Thank you.
Okay. I'll inform. Everything will be informed. Don't minute to minute communication will be there. Don't feel tension. So minute to minute communicate. I'm here for you. Everything. Okay. Yes. Don't worry. I'm the contact point. So you don't worry. So everything you can ask me. Minute to minute communication.
Thank you.
Okay.
Okay, sir.
Minute to minute you can communicate with me. Minute to minute. No worry. Okay. Yeah. So this is the last class. Yes, about Java introduction discussed last class. Java introduction. Yes, Java. Yes. So Java is interpreter based as well, compile based. See here, this guy is unable to hear me. Please rejoin the session. Ashish Yadav. I think yes, he's on offline. How you can reach? See, Ashish Yadav. Yes, he's in offline. He can't hear anything. He's in offline. Yes, rejoin the session. Rejoin the session. Yeah, this guy is in offline. Okay, we're not in online here. This guy is offline. Rejoin the session. Now he's okay, I think. Now Ashish Yadav, now he's okay. Now he came to online. He can hear me now. Fine. Everyone is online only. I think everyone can hear me. Now, yes, let us start session. So yesterday's class is about this introduction. Java introduction. Java is interpreter based as well, compiler based. The topic discussed. Today topic about Java features. Okay, 1 second. Just a minute. Yes, reverse. Day 2. See, day 1 all the introductions. Day 2 Java introduction. Yes, in this JDK 1.0 released with these features, right? Okay, released with these features. So this is today topic. Yes, to understand all these features, last 2 classes prerequisites. Yes, about we discussed last 2 classes. About OS discussed. About interpreter compiler discussed. About low level, high level language discussed. Okay, the prerequisites. Okay, last topics. These basics. Okay, like system software, application software. Next, about OS discussed. So next, front and back end language packages, low level, high level languages. These are all the prerequisites to understand today's topic. Okay, these are the prerequisites. Interpreter compiler. These are all the prerequisites for the today's topic. Okay, today's topic. Okay. See, if I explain directly today's topic, yes, you can't understand. If I explain direct today's topic, you can't understand. That's the reason all the basics were explained. The basics were explained. Okay. Yes, today's topic, no doubt you'll see wonderful session today. You'll see wonderful session today. Yes, 1 second. See, first one, Java is an independent platform. Yes, what does it mean? What does it mean? What does it mean? See, platform means what? See, last class we discussed about OS. Previous class about OS discussed. Previous class about OS. OS is a platform where we can run application software. So OS acting as platform, right? OS acting as platform. On top of OS, all the softwares are running. OS is a platform. Yes, so here platform means is OS. Okay. Java is an independent platform. Java is an independent platform. What does it mean? Okay, means here Java program can run on any OS, any application. Java program independent platform. It means Java is an independent platform. Means yes, Java program can run on any OS. Okay, fine. Okay, Java program can run on any OS. No question is here. Question is how. Yes, 1 second. Question is how Java made as independent platform. Yes, independent. Yes, independent platform. Yes. So how Java made us independent platform? How Java made us independent platform? This is a question. Yes, how to answer?
It contains .class file.
Yeah. No, I'm not asking you. This question I am not asking you. Okay, this question I have to explain this one. So how Java made us independent platform? Suppose when you're facing interview here, Java is an independent platform. Yes, somebody is asking what are the main features of Java? Independent platform, you immediately answer. So when you say independent platform, immediately you will ask that what does it mean? Then Java program can run on any ways. How? Immediately we'll ask the next question, how Java made us independent platform? Yes, let us see. Yes, to understand this concept here, directly may not be understanding. To understand this concept here, first of all, you must have the Exe file knowledge. Yes, about the Exe file. Let us see about Exe file. Yes, some question for you guys. Exe file prepared on Windows OS. Exe file prepared on Windows OS. Can I run on Linux? Yeah, these also may be some interview question. Yeah, these also interview question. Okay, Exe file prepared on Windows OS. Can I run on Linux OS? Yeah, this also important interview question. Yes, anyone can answer this with your knowledge. Suppose some working guys are there. Some working guys, maybe some student knowledge. Yes, Exe file prepared on Windows OS. Here chat box available in chat box. Yes or no? 1 second. Here chat box available. In chat box you can share your answer. In chat box you can share your answer. Say yes or no. Okay, yes. Exe file. Yes. Answer is no. Answer is no. So generally most of the guys says that no. Fine. Why Exe file is very dependent? Why immediately question getting? Why exe file is OS dependent? Yes, anyone can you answer this one? Why exe file is OS dependent? Of course, I'll explain. Of course, I'll explain. Okay. See, exe file prepared on on Windows OS. Can I run on Linux OS? Linux, no. Reason is yes, exe file is a OS dependent. Reason exe file is a OS dependent. OS dependent. Exe file is a OS dependent. OS dependent. Okay. Yes. Exe file prepared on Windows OS. Can I run on Linux OS here? No. Answer is no. Reason exe file is a OS dependent. Okay. Yes. If exe prepared on Windows OS, we can run only on Windows OS. Suppose exe file prepared on Linux OS, only on Linux OS we can run. Exe file is a OS dependent. Exe file is a OS dependent. Now immediately question, yes, can you explain why exe file is OS dependent? Yes, maybe asking this question. Can you explain why exe file is OS dependent? Okay. Yes, how to answer this question? Yes, to answer this question, you must have the exe file knowledge. Yes, about exe file knowledge. See, for example, here C program, yes, exe file prepared. C program exe file prepared on Windows OS. On Windows OS, C program exe file prepared on Windows OS. Then it contains what? It contains what? Yes. First, let us see Windows-based exe file. Next, we'll discuss Linux-based exe file also. Now, Windows-based exe file. Next, Linux-based exe file also we'll see. Yes, open C program. Yeah, this is your C program. Windows-based C program. This is Windows-based C. Linux-based C also we'll discuss today. Okay. Yes, math.cpp. One second, let me check program. Yeah, fine. Compile. Yes, run. First number 10, second number 20, addition 30, subtraction -10, multiplication 200. Okay, fine. Okay, fine. Okay, fine. Now running math.cpp. So math.cpp. C drive, TC, yes, bin folder, math. One second. The existing files, others files I'm deleting. Yes, see math.cpp file. Math.cpp. Okay. Now I'm compiling. That math.cpp. See this. Yes, even backend you can open this math.cpp. So this is math.cpp file. Math.cpp. Okay. Now let us compile. Yes, compile. See when you compile backend, some file generated. In backend, some file generated. Okay. See, it's object file. Right click, properties, check it. Yes, math.obj. So what is this object file? This object file contains binary code for our C program. This object file contains binary code for our C program. So by this is our C program, wide main, yes, complete C program that contains binary code of our C program. That math.obj file. So math.obj file, math.obj that contains binary code for C program. Right? Okay. Next here there are some predefined libraries. std.io.h, conio.h. There are predefined libraries. These predefined libraries also contains binary code. This predefined library also contains binary code. This predefined library also contains binary code. Okay, fine. Okay, for our program, for our C program, binary code is math.obj. This is math.obj. Math.obj contains this math.obj file contains binary code for our C program. Okay, correct. Next, See, std by data, they are predefined libraries. That are second predefined binary code, some predefined binary codes. Okay, now I'm running this program running. Yes, see some exe file created. Math.exe file created. See 9:38 a.m. 1/7 July 9:38 a.m. Just now exe file created. That how exe file creating here? How that exe build happens here? Okay, see 10, 20. So yes, that how that exe file creating here. When you try to run it here, yes, first it will create exe file. How that exe file creating here? Yes, for creation of exe file, that C comparer taking yes math to be say means binary code for your C program, binary code for C program. Okay, binary codes, yes, binary codes, binary code for C program, binary code for C program plus C program exe file prepared and inverse ways, then it contains binary code for C program plus yes taking binary code for C program plus binary code for this library, C software library, C library plus binary codes, binary yes binary codes, binary code for C library, binary code for C library plus next yes in OS there is a library. In OS there is a library. OS contains library. OS contains library to communicate between application software and hardware. So OS library. These libraries are in binary format. OS library also binary format. OS library also binary format. Okay. So next binary code for yes next binary code for now Windows OS library. So C program exe file prepared on Windows OS. Then it contains binary code for C program, binary code for C library, binary code for yes Windows OS library, Windows OS library, Windows OS library. Okay, by linking all of this in exe file generates. See at the time of creation of exe file, when you run this one here, exe file creates. So compiler by linking all of this in generating one exe file. After generating exe file, then execution, then getting output. Now what's happening here? Here exe file, that exe file linked with OS library. That exe file linked with Windows OS library. Okay, C program exe file prepared on Windows OS. Then it contains binary code for C program, binary code for C program, binary code for C library, binary code for OS library. That means that exe file is linked with OS library. Exe file linked with OS library. Okay, let us take one more example. Linux example. Linux. Let me start Linux OS. Linux. Yes, I'm starting Linux OS. Yes. Next, C program exe file prepared on Linux OS. Then it contains binary code for C program, binary code for C library, binary code for Linux OS library. Now library changes. Linux OS library. Yes, now in Linux you can see practically. Okay. See Windows based C language here. Backend compiling, backend creating exe file automatically. This IDE. In IDE happens everything. But in Linux, yes, manually. Yes, all are manually. Now you can see clearly the steps to compile, steps to create exe file, you can see manually. Okay, you can understand very clearly now. You can understand very clearly. Now you can understand very clearly. Yes, Linux terminal. PWD, present working directory, ls, list of files. See, you guys don't think about Linux commands. Our topic is not Linux based. Our topic is not Linux based. Topic is about exe file. Topic is not about Linux based. Topic is about exe file. Okay. CD change of directory to mnraw. Here this is some mnraw directory changed. Yes, present working directory mnraw. We are at mnraw directory ls. Its contents. Okay, one second. Yes, I'm removing some files here. See, present working directory mnraw in this they say test.c file gedit test.c. Yes, like a Windows notepad. gedit is like a Windows notepad. See, yesterday Windows notepad used it. Previous class Windows notepad used for Python scripting and Java programming. Notepad used same. Linux notepad. It's a Linux notepad. Linux notepad. gedit test.c. Yes, opening test.c. Yes, this is a file. Okay, the C program. Okay, C program. A equal 10, B equal 20. Same. Addition, subtraction, multiplication. Okay. It's yes, this program. Now this program we should compile it. See GCC -c test.c. GCC is a Linux based compiler, C compiler. GCC is a Linux based C compiler. Yes, compiled. See here also .o file generated. Test.o file. Here also test.o file generated. 1 second. Remove start.o. The test.o file object file removed here. gedit test.c. Suppose there are some mistakes. There are some mistakes here. Okay. Suppose some mistakes. Here are suppose some mistakes. Some mistakes. Yes, save. Okay, now yes, let us compile here. Yes, GCC -c. Just the compilation is test.c. See compile. Yes, compiler shows all errors from top to bottom, right? Yes, yesterday's class we discussed about compiler. Compiler shows all errors from top to bottom. See 10th line error, 12th line error, 14th line error, next 18th line error, so next 25th line error. So compiler shows all the errors from top to bottom. This is yesterday point. Yesterday topic. Compiler showing all the errors from top to bottom. Top to bottom, right? Top to bottom. Okay. Yes. Now let us correct all that mistakes here. Here semicolon missing. This statement here comma missing. Here double quotation missing. Okay. Next this statement semicolon missing. Yes. Here semicolon missing. Fine. Save. Save and close. Okay. Save and close. No. ls. Yes. GCC -c test.c. Yes. No error. If no error, test.o. It's object file. This object file contains binding code for our C program. The test.o file. Test.o file. Test.o file contains binding code for this your C program. Next, std_out. It's a predefined library. This predefined library also having some binding code. The predefined library also having some binding code. Predefined library also having some binding code. This also having some binding code. Okay, right? Yes, fine. Now creation of exe file. GCC-o. Now we should convert into exe file. Suppose let us say exe file name is project. Project is exe name test.o. Now this test.o converting to exe file. Result exe is project. Project exe file series. Project exe file created. Now /project. I'm running that exe file series. Exe file output. Exe file directly executed. One exe file generated. That exe file executed now here. Exe file executed here. Addition, subtraction, multiplication. Okay. Yes. Here practically you understand how compiler working. See in Windows based here, this is Turbo C IDE. So backend everything happened. Now Linux manually created exe file. That project exe file. That exe name is project exe. Okay, right? Project exe. Okay, see here creating exe file. See that exe name can be anyone. Suppose I'll use some name Durga. Yes, by name of Durga exe file created. No running the Durga exe file. Same one. So this exe file contains what? This exe file at the time of creation of exe file, at the time of creation of exe file, that C compiler taking binary code for our C program plus binary code for C library plus binary code for Linux based library. By linking all of them, generating that exe file. So this project exe file, that Linux based project exe file, that project exe file, that project exe file, yes, contains what? C program exe file prepared on Linux based. Then it contains binary code for C program, binary code for C library, binary code for Linux based library. That is exe file. Complete exe file is like this. Yes. Now let me show that exe file, gedit project exe file. Yes, I'm opening that exe file. Yes, exe file contains completely binary code. Exe file contains completely binary code. See that exe format. Yes, machine language. That exe format. It's a binary code complete machine language. It's a system understandable language. It's a system understandable language. Okay. Yes. Next, one more thing. In Linux, they say file command to check the type of the file. Test.c. Yes, what is type of test.c? I'm checking here. File. File is a command to check the type of your file. Test.c. What is test.c? It's a C source ASCII text. Now this file command saying that this test.c program is a C source ASCII text. Now let us check project exe file name. Yes, project is exe file, right? The project, what is type of this file? What's the type of this file here? Yes, check it. See, projects, it's a executable file. Okay, x86 means 8086 processor. In my system, 8086 processor using here. Next 64 bit ways using here. So 8086 processor and 64-bit ways. Okay, right? Next series ld-linux x8664.so. Okay, .so. It's an extension for the OS library. .so means it's a OS library. It's an extension for the OS library. So this is Linux OS library. That means this project executable file, that exe file prepared on Linux and linked with this Linux OS library. So project exe file contains Linux OS library. I think you understand, right? That Linux OS library is now linked with project exe file. That project exe file contains now Linux OS library. That's it. Okay. Yes. Suppose let us take one more example. Another example. Suppose C++ program exe file. C++ program exe file prepared on Windows OS. Then it contains binary code for C++ program, binary code for C++ library. C++ library example iOS team data setter file. Yes, binary code for Windows OS library. Yes, binary code for Windows OS library. Now what is happening here? Yes, exe file generating on Windows OS or Linux OS, any OS. That exe file is always linking with OS library. So exe file yes is always yes linking with OS library. Yes, at the time of generating exe file, at the time of generating exe file. Yes, it is called as statically linking. Yes, it is called as statically linking. Okay, statically linking. It is called as statically linking. So at the time of creation of exe file itself, OS library linking with exe file. At the time of creation of exe file, see exe file always linking with OS library at the time of generating exe file. So it is called a statically linking. So OS, yes, So here OS library statically linking with exe file. So here OS library. So OS library statically linking with exe file. That's it here. So OS library statically linking with exe file or vice versa. So you can see exe file statically linking with OS library here. Okay. Or you can say like reverse, no problem. Exe file statically yes linking with statically yes linking with OS library. Yes, anyone you can say, no problem. Vice versa, no issue. So exe file statically linking with OS library. Okay. Yes. Now see, let us take one exe. Suppose test.exe file. Okay, test.exe file prepared on Windows OS, on this OS, Windows OS, then it links with Windows library. Right? Links with Windows library. So for example, test.exe file prepared on Windows OS here, then it links with Windows library. So test.exe file with test.exe file with Win library on different operating systems. Yes, on different operating systems. Let us see on different operating systems. Yes, how it will work on different operating systems here. Test.exe file with Win library. Yes, working on different operating systems. Working on different operating systems. Yes, let us take different platforms here. Yes. Let us take different platforms. See, your computer here, this is a hardware. Okay, 1 second, just a minute. Here, just a minute. Yeah, 1 second. One second. One girl not joined. Yeah, Pawan is joined. Okay, fine. Yes, okay, fine. I think not joined. I thought of not joined. Okay, fine. Yes. Okay, now, so test.exe file. The test.exe file with Win library working on different operating systems. See, hardware. Yes, computer. Hardware. On top of hardware, this is OS. Right? Hardware. On top of hardware, OS running. Okay. Let us say Windows OS. Windows OS with Win library. Windows OS with Win library. Windows OS with Win library. Okay, Windows OS with Win library. Okay. Yes. Now, on top of it, program running. So previously we discussed OS is a platform on which everything is running. OS acting like a platform. On top of it, everything is running. Now test.exe. Test.exe. So when you try to run test.exe file, what happens here? See here test.exe file, test.exe file with Win library. So when you try to run test.exe file, now this test.exe file, it will try to call to Win library. It will try to call to Win library. Win library. It will try to call to Win library. That Windows OS library. So when you try to run test.exe file on Windows OS, here on Windows OS, now this test.exe file, it will try to call Windows OS library. Reason? Yes, already linked. Yes, linked with Windows OS library here. Since test.exe file, linked with Windows OS library, it will try to call to Windows OS library. It will try to call to Windows OS library. Yes, here it's available. Using that library, it communicates with hardware components. That's it here. See, previous class, yes, in OS topic, every program has to link with OS library before going to run it. Every program has to link with OS library. Every program has to link with OS library. Every program has to link with OS library before going to running. Before going to run, every program has to link. Every program has to link with OS library before going to run. Okay, every program has to link with OS library before going to run. Now, what's happened in case of C language here? That exe file at the time of creation of exe file itself already linked. At the time of creation of exe file, yes, already linked, right? Already linked. Already linked. Okay, since linked with Windows OS library, it will try to call Windows OS library. Yes, here it's available. Using that library, it will communicate with hardware. That's it. So successfully completing that program, successfully completing on Windows OS. Now same program, yes, on other platforms. Same test.exe file with Win library on Linux OS. Linux OS with the Linux library. Linux OS with Linux library. Now, when you try to run test.exe file on Linux OS, what happens here? Now this test.exe file, it will try to call Windows OS library because Windows OS library already linked with test.exe. Since test.exe file linked with Windows OS library, yes, it will try to call to Windows OS library, but not available. See, Windows OS library becomes part of exe file that's plugged into that test.exe. That Windows OS library already plugged. Okay, that will plug in into Windows OS library already plugging into test.exe file. It will plug in, means it becomes part of exe. That OS library becomes part of exe file. OS library becomes part of exe file. Not test.exe file. It will try to call Windows OS library, but here is not available. Library is not matching simply fails. That library is not matching simply fails. That OS library is if OS changed, that library is not matched. That library is not matched simply failed here. Okay, let us take another ways. Suppose Mac OS with Mac library. Mac OS with Mac library. Same thing happens here. Here also it will try to call to Windows library, but library is not matching. Different library here, right? Not matching, again fails here. Again fails. Again fails. So that's the reason exe file is OS dependent here. So exe file is OS dependent. Okay. See, since exe file statically linked with the OS library. Yes, OS library. Yes, it is an OS dependent here. It is an OS dependent. It's an OS dependent. That's it here. Okay. Yes. Now here question. What is our question here? Yes. Why exe file is OS dependent? Okay. Reason exe file contains OS library. Simple answer. Very simple answer. Exe file contains OS library. Very simple answer. Exe file contains OS. Very simple answer here. So why exe file is OS dependent? Reason it contains OS library. It contains OS library. Okay. Since exe file contains OS library, it's a OS dependent. Yeah, that's all about exe file. Now let us come to Java. Yes, now you can understand Java very clearly. Now you can understand Java clearly. Yes, now let us say about Java dot class file. See, Java dot class file is independent platform. Yes, how dot class file made us independent platform? Let us see. See, Java dot class file. Yes, is an independent of platform. Independent of platform. Yes, independent of platform. Okay. Yes, independent of platform. Yes. Now, how dot class file? How dot class file? Yes, made us independent of platform. Yes, how independent of platform? Independent of platform. How independent of platform? How Java dot class made us independent of platform? Yes. Same that example. C program example. Now it's a Java program. Now Java program. Now Java program. See Java program. Java from program dot class, right? In Java is a dot class, no exe file. Previously we discussed no exe file. So Java program dot class file. Java program dot class file prepared in this ways. Yes, Java program dot class file prepared in this way, then it contains what? Yes, anyone can you guess it? Anyone can you guess it, you guys? Java program dot class file prepared in this ways. Java program prepared in this way, then it contains
Bytecode.
Bytecode.
yeah, good bytecode. It's a bytecode for Java program, bytecode for Java program plus next
Binary
what?
code.
Not bytecode for Java library, bytecode for Java library also in byte format. Reason Java library also developed in Java. See, C language library developed in C language. C++ language library developed in C++ language only. Python library in Python. Java library in Java. Okay. So dot class file prepared and Windows based, then it contains bytecode for Java program, bytecode for Java library. Next, binary code for OS library. No, don't have this part. No, OS library never links to dot class file. Okay, OS library never linking to dot class file. OS library never linking to dot class file. Now, bytecode for Java program, bytecode for Java library. That's it here. That's it. No OS library. See, Java library also developed in Java. That means pure Java program. Yes, no OS library in this. No OS library. It's a pure Java program. Okay. See, dot class file. Dot class file is a pure Java program. Pure Java program in byte format. Pure Java program in byte format. Dot class file is a pure Java program in byte format. Dot class file is a pure Java program in byte format. Java program, a dot class file is a pure Java program in byte format. Okay, so dot class file. See dot class file. Yes, don't have any OS library. Dot class file don't have any OS library. Dot class file. See, dot class file don't have any OS library. So dot class is now free from OS library. So dot class file is free from OS library. Don't have any OS library. That is about dot class. Dot class file is a pure Java program byte format. Dot class is a pure Java program byte format. So dot class file don't have any OS library. Dot class file don't have any OS library. It is free from dot class file, free from OS library. Okay, fine. Now, for example, tested dot class file. See, the dot class file may be prepared on any OS, no OS library. Dot class file prepared on Windows OS or Linux OS, Mac OS, Unix OS, Solaris, you take any OS. The dot class prepared on any OS, but don't have any OS library. Okay. Yes, dot class file. See dot class file. Yes, maybe generated on anyways. Yes, it don't have. Yes, OS library. Don't have OS library. Yes, that may be generated on anyways. You don't have any OS library. Okay, right? Now, so tested dot class file. Tested dot class file working on different platforms, working on different operating systems, Let's see how it's working on different operating systems. Like exe file, how tested dot class file working on different operating systems, how tested dot class file working on different operating systems. Now let us take different platforms. First one, Windows platform. Hardware, Windows OS Win library. No, on this test.class file. Test.class file. Not tested.class file running on Windows OS. Can I run on Windows OS directly? No. Yes, we can't run this tested.class file directly on Windows OS. Reason here. See, this ways discussed. Every program has to link with OS library. See, every program has to link with OS library before going to run. Okay. So every program has to link with OS library before going to run. Why linking with OS library? To communicate with hardware. Yes, how program can communicate with the hardware? That has to communicate through the OS library. Every program has to communicate with hardware through the OS library. Compulsory OS library required. Otherwise, cannot communicate with hardware. Required, correct? So every program has to link with OS library. Now come to Java.class file. Yes, is it linked with OS library? No. Where that link here? No link. Test.class file not linked with OS library. Then how it work? No, it cannot work. Test.class file cannot work directly here. Test.class file can't run directly. It has to link. Now this tested.class file also has to link with OS library. Otherwise cannot run. Here. Now tested.class file has to link with OS library here. Who will link it here? For linking purpose between tested.class file and Windows OS. Yes, one more layer comes. What is that layer? Anyone can guess it. Between tested.class file and Windows OS, one more layer comes. What is that layer?
Compiler.
No, compiler already over. Compiler job is done already. Compiled and got the dot class file.
Interpreter.
JVM.
Interpreter. Yeah, JVM. No, JVM comes to picture. Now JVM comes to picture. Java virtual machine. JVM means Java virtual machine. Now JVM comes to picture. So JVM taking tested.class file, and linking with Windows OS library. Once link established, then execution starts generating output. So JVM has to link. So when you're running tested.class file in Windows OS here, JVM taking tested.class file, linking with Windows OS library, after linking, then executes, getting output. That's it, getting output simply. Okay. Now same test.class file on another platform. Let us take another platform. Yes, another platform. See another platform. Let us take another platform. Yes, another platform. See, Linux base. No Linux base. With Linux library. See, on Linux base also there is JVM. Now Linux JVM taking tested.class file. Links with Linux OS library. Once linked with Linux OS library, then communicates with hardware. That's it here. So what is happening here? Tested.class file. If it is running on Windows OS, linking with Windows OS library. Same test.class file, if it is running in Linux OS, then linking with Linux OS library. Suppose, let us take another platform. Suppose, yes, Mac OS. If it is running on Mac OS here, then links to Mac OS library. So Mac JVM. On Mac OS of this JVM, that JVM taking test.class file, yes, links with Mac OS library. Once linked, communicate with hardware. So what is happening here? Every time of changing with that link changing. So whenever OS changing, see, if dot class file is running on Windows OS, linking with Windows OS library. Same dot class file if it is running on Linux OS, linking with Linux OS library. Same dot class file if it is running on Mac OS, links to Mac library. If it is Unix OS, links to Unix library. If it is Solaris, links to Solaris library here. So every time of changing OS, that link changing. This is called a dynamical linking. Dynamically. Okay. Yes. See dot class file. See Java dot class file. See Java dot class file. Java dot class file dynamically. Yes. Linking with yes. Dynamically. Yes. Linking with OS library by the JVM. Okay, 1 second. Yes, Preetham, just wait. I'm coming to same topic. I'm coming to your doubt only. I'm coming. Wait. Java dot class for dynamically linking with OS library by the JVM. Okay, by the JVM. Okay, since Java dot class file, say dynamically means changes. Statically means fixed. Static means fixed. Dynamic means changes. See, static behavior, dynamic behavior means what? Static behavior means always same. Fixed, that behavior fixed. Dynamic behavior means, but that behavior changes accordingly, right? According to the situation, that behavior changes. Okay, now it's a dynamic linking. C program Exe File, the static linking. Yes, Exe File. See, at the time of creation of Exe File itself, statically linking. That link never changes. Link is fixed. Exe file, OS library linking, that is fixed. That never changes. That linking never changes. It's a statical linking. Since statical linking, it's a OS dependent here. Since statical linking, okay, since Exe file statically linked with OS library, it's a OS dependent. When come to Java program, yes, since Java dot class file dynamically linking with OS library by the JVM, yes, it's an independent platform. It's an independent. Yes, independent platform. It's an independent platform. Right? Fine. Okay. So why Exe file is OS dependent? Reason, OS library statically linking. Why dot class file is independent? Reason, dynamic linking. That's it here. Not only here, any program static link is a OS dependent. Dynamic link is a OS independent. See, even Python scripting also dynamically linking with OS library. Python scripting also dynamically linking with OS library. Since Python scripting is dynamically linking, Python is independent platform. Python also same. Python language also. Yes, sorry. Python scripting also linking with OS library dynamically. So every time of changing OS, that link changes. Okay. So Python and Java both are independent platform. Reason, they are dynamically linking with OS library. Okay. Okay, fine. Yes, everything is fine. Okay. Now question is here. Not JVM for Windows OS from JVM, Linux OS JVM, yes, Mac OS JVM, right? Now question is here, JVM, is it part of OS? JVM, is it part of OS? No. So here OS is somebody product, JVM is some sort of product, right? JVM is from some company, OS is another company. It's not a part of OS. JVM is different, OS is different here. JVM is not a part of OS. JVM is not a part of OS. Okay, JVM is not a part of OS. Okay, yes, JVM is not a part of OS. JVM, yes, JVM, yes, not a part of OS. Yes, it is from, yes, it is from JDK. It is from JDK. It is from JDK. Okay, it is from JDK. Okay, see, Sunsoft has developed different JVMs. Yes, different JVMs. 1 second. Once this point later, just a minute. JVM is not a part of OS. It is from JDK. It is from JDK. Okay. Yes. Now, yeah, how to get JVM? Yes, to get JVM on your system. To get JVM on your system. Yes, on your system, JDK should be installed. JDK, yes, should be installed. JDK should be installed. So once JDK installed, to get JVM on your system, okay, to get JVM on your OS or system, yes, JDK should be installed. Once JDK installed, we can get the JVM. So once JDK installed, we can get the JVM. Okay, fine. Now here's some interesting points here. Java.class file is an independent of OS. But JVM is a OS dependent. JVM is a OS dependent. Okay. Java.class file is independent of OS. But JVM is a OS dependent. Reason JVM is a C++ exe file. Yes, wherever exe concept is a OS dependent, right? JVM developed in C++. JVM is a C++ exe file. JVM is a C++ exe file. It's a C++ exe file. If it is exe, no doubt it's a OS dependent. JVM is a OS dependent. Okay. Yes. See, Sunsoft has developed different JVMs for different operating systems. Right? Sunsoft has developed different JVMs for different operating systems. Okay. Yes. Now, Pritam, 5 question is answer. There are different JVMs for different operating systems. There are different flavors available: Windows flavor, Linux flavor, Unix flavor. Different flavors available. Different JVMs available, different operating systems. Okay, different JVMs available for different operating systems. Reason here, yes, JVM. This JVM understanding Windows base. This JVM understand Linux base. This JVM. See, Windows JVM can understand Windows base. Linux JVM can understand Linux base. So Mac JVM can understand Mac base. One JVM cannot understand every operating system. No, not possible. So one JVM cannot understand different operating systems here. JVM also independent of is not possible. Reason I'll tell you. JVM is exe file, right? If it is exe file, that exe file also contains JVM.exe file. Yes, if it is exe file, that exe file also contains OS library, right? So Windows JVM linked with Windows OS library. Yes, Linux JVM with Linux library. Yes, Mac JVM with Mac library. Means this JVM running on specific OS here. Windows based JVM running on Windows OS here. Linux JVM running on Linux OS here. Because that exe file is OS dependent. Exe file is OS dependent. Okay. So Windows JVM, yes, having knowledge of Windows OS library, so it can link test.class file with Windows OS library. Linux JVM is having knowledge of Linux OS library, then it can link with Linux base here. Okay. Yes. Next, Mac JVM is now knowledge of Mac library, can link with Mac OS. That's it here. Okay. See here. See. Dot class file, Java dot class file is independent of OS, but JVM is OS dependent. JVM is a C++ Exe file. Sunsoft has developed different JVMs for different operating systems, different JVMs for different operating systems. Okay, right? Yes. See, since JVM is OS dependent, okay, OS dependent, JDK also 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 OS dependent. Since JVM is OS dependent, JDK also OS dependent, JDK also OS dependent. See drive. Yes, JDK 8, JDK 9. JDK 8 for Windows, JDK 9 for Windows based. It's a Windows based JDK. Yes, let us go to Oracle Corporation site. Yes, downloads JDK 1.8. Downloads. See the downloads. See here. There are all the downloads. I said downloads. JDK for Linux, JDK for Mac OS, JDK for Solaris series. These are Linux JDK. This is Mac JDK, Solaris JDK, next Windows JDK. That is here. Okay, different JDK is available here. So for every way separate JDK, you have to download it here. JDK is also OS dependent here. So different operation, different JDK you have to develop. You have to download it. That's it. Yes, you guys need to download here. I will provide. It's there in drive. JDK available drive. See JDK Eclipse. 1 second. Don't try to use your own Eclipse and own JDK because version compatibility problem. You guys don't download Eclipse. Don't download JDK. Of course, you can download JDK, no issue. But when come to Eclipse, the version compatibility problem comes. Version compatibility. All versions are not working same Eclipse here. Different versions of JDK, different Eclipse. Okay. Yes, in drive it's available. Eclipse available in drive here. Eclipse, JDK, both are available in drive. Yes, you can download only that here. Don't download others here. Just you download only our drive softwares here. Yes, just you download only. Yes, download from our drive. Don't download from the other sites because version compatibility problem. Yeah, there is a version compatibility problem. Yes, tomorrow, of course, tomorrow we are going for installation. The Java installation tomorrow topic. See JDK 8 Windows based, next Eclipse Windows based. Okay, that version compatibility. Okay, yes. So this is independent of platform. Okay, yes. How would Java made us independent of platform? This is the reason for this. Okay, now exe file dot class file. What's the difference? See about exe file, about dot class file, we have discussed very clearly. Exe file dot class file discussed very clearly. Now let us see difference here. Exe file dot class file comparison. Exe file dot class file comparison. Exe file, it's a binary code file. Dot class a byte code file. See first difference. Binary code and byte code. Exe file, system understandable language. Dot class for JVM understandable language. Get these 2 points. Anyone says, any website says these 2 points. Any website, any trainer says these 2 points. Yes, here important point. Main difference is OS library. Exe file contains OS library. Okay, dot class file don't have any OS library. Dot class file is free from OS library. This is main important point. This point no trainer will touch. I'm sure. Okay, no Java trainer will explain topic like this because they don't have about embedded C knowledge. Yes, see, to explain this topic, they must have the embedded C knowledge first of all. How that exe file creating, that exe file contains what? See, practically I have showed about exe file and Linux base. Linux base I showed practically. See, my first 4 years of experience is embedded C. First 4 years I worked on embedded C, later switched to Java, later switched to Java. Okay, yes. So because of that experience only, I'm able to explain very clearly. It's all my experience. Okay, yes. See, first difference, binary code, byte code. Binary code, byte code. Next difference, exe file contains OS library. Dot class file don't have any OS library. Okay, exe file is a prepared file for specific OS. Exe file is a prepared one for specific OS, but dot class is not prepared for specific OS. Dot class file is not for OS here. Okay, it don't have any OS library. Next, one more important difference. OS library statically linking with exe file. Here OS library dynamically linking here. Okay, see exe file contains OS library. Dot class file don't have OS library. Next, exe file. Yes, statically linking with OS library. Here is a dynamical linking here. Dynamical linking. So the difference here. Okay, see exe file is already prepared. Already prepared. Directly executes. But dot class file is not prepared. Dot class file is not prepared. After moving on to OS, JVM prepares as per the current OS. Yes, if current OS Windows OS, linking with Windows OS. If it is Linux, linking with Linux OS. That's it here. Okay. See, exe file executes somewhat faster than dot class file. Because exe file is already prepared, means already linked with OS library. Exe file is already linked. Since already linked, it directly executes. But dot class file linking at runtime, right? Since dot class file linking at runtime is executing slowly. Okay, right? Compared to exe file, somewhat slow. Okay. Next, one more thing. To run exe file, application software not required to install. What does it mean here? To run exe file. See. So the Linux. On Linux base here, there is a project exe file created. Same Linux, Ubuntu Linux. Here Ubuntu Linux, here Ubuntu, here Ubuntu, here Ubuntu. Okay. See. On this Linux base, C software installed, GCC, C compile it's here. Installed. Okay. C compile installed. C software installed. And we got the project exe file. Now this project exe file, I can move to next another Ubuntu Linux base and I can run directly. On another Linux base, again C software not necessary. That C environment is not necessary. That C software not required to install. Without installing C software, also you can run that exe file because exe file is already prepared over preparation. Already OS library linked, already software library linked, and everything linked, already prepared. Exe file is already prepared. So again OS library not, yes, again C software not necessary. Again C software not necessary here. Okay, so to run this exe file, that software is not necessary. To run exe file, application software means C software. To run exe file, that application software, C software is not required to install. But to run dot class file, JDK should be installed. Why JDK installed? JVM purpose. To run dot class file, JVM required. To run dot class file, JVM required. For the purpose of JVM, we should install JDK. That's it here. So once JDK installed, we can get the JVM. If JVM is available, we can run dot class file. To run the dot class file, JDK software should be installed on every OS, otherwise cannot. So this is difference between exe file dot class file. That's it here. That's the difference. So this is yes about this is about independent platform. How Java made us independent platform. Okay. See this topic, this kind of explanation. No Java trainer will explain. I'm sure no Java trainer in India, no Java trainer will explain. Even in world, no website will give information like this. No website provides information. Just to try for independent platform in Google. Yes, no website will give this kind of explanation. Next, you try for difference between exe file dot class file. Only one difference: binary code, byte code. Exe file is OS dependent, dot class file independent of that. That's it here. But you want this kind of explanation. That OS library nobody will explain. Yes, practically explain all this. Okay, yeah, that's all my experience. See, my experience is more than industry, Even Google also cannot reach my experience. Okay, even Google also will not give that kind of solutions. I'll give that kind of solution Java. I'm very expert in Java, expert in Hadoop, and expert in embedded C. Expert in embedded C, Java, Hadoop, and Linux OS. Expert in this area. I have primary skills in the software. See, software professional who is having Linux knowledge, Java knowledge, Hadoop knowledge, and Python experience. Embedded. This is what highly profile skills. Java, Linux, Python, Hadoop. It's not easy. Yes, 20 years, more than 20 years, 22 years, how good in this area. 22 years of experience. Because of that one, I got this knowledge here. Okay. See, going forward, you will see sessions better than today's session. Every session looks very interesting. Yes, it's my promise. It's guaranteed here. Every session looks interestingly here. Okay, better than today's session. Yes, today's session, no doubt, wonderful session. Today's session, wonderful session, no doubt. Better than this session, I can show going forward. Everyday session looks like this only here. Very interesting, practically I'll show. Okay, yeah, that's all for today. Yes, any doubts? Yes.
Sir, I have a personal concern. Can I call you after this session?
Yeah, sure, definitely. Sure,
Yeah.
100%.
Yeah,
Anytime.
yeah, I'm Sujit. Yeah, I'm Sujit. I will call you, sir, in 5 minutes.
Yeah, definitely. See, one second.
Yes,
See, I'm very free. I'm not a commercial. Okay, just you can feel like your brother or your parents. Anytime you can call me, any kind of things you can ask me. Okay. Yes, 24/7, anytime. Okay, anytime, except night 12 to morning 6, 12 to 6, except that anytime I can talk. Okay, even last night at 12:45, some guy called me, some asked doubt. Yes, I responded at 12:45 also. Yes, because at 12:45 I'm working. I'm in online. Because of online, yes, I think he has called. He checked my WhatsApp status. He's online showing, so he called me immediately. Yes, I responded. I answered him clearly. Answered and explained doubt also. Okay. Yes, that guy also can. Yes. So when if I'm free, definitely even night hours also responding. Okay. This guy, who is this guy? Yes, night. So Subramanian, this is 12:31. Yes. Communicate with me. Doubts. See this program. This program is asked this. Sir, this program is not running. Then what can I do? He shared a message. I replied. Okay, yes, 12:40 time. Okay, not on this guy can see this. This guy 12:19 AM, 12:17, 12:06, 12 o'clock after midnight also. 12:06, 12:07, 12:19, 12:31, 6:17 early morning. Started 6 o'clock. Yes, that communications. Okay, yes. So that means yes, anytime you can call me. No problem, no issue. Okay. Yes, I think tomorrow it will be paid link, I think. Okay, tomorrow I think it's a paid link. Still anyone pending is there, just you can communicate with the online team. Okay, right? Yeah. So thank you guys. Thank you guys.
Sir, can you provide the driver link, sir?
Yeah, sure, definitely.
Okay.
Okay. No worry. Okay, yeah. Thank you guys. See you tomorrow.